Hi, everyone. I'm Arpit. I'm the lead PM for Android Go.
And hi, I'm Patrick. I'm the technical lead for Android Go.
All right. So I want to start first by sharing a personal story. Back in 2010, there was a spike in farmer suicides in India following a really, really terrible monsoon season. I was very moved by it. A bunch of friends and I got together, and we started a company to serve weather insurance to the farmers of India. We traveled through states of Maharashtra and Andhra Pradesh to meet these farmers, talk to hundreds of them, and test our prototypes out. What I learned was very astonishing. It appeared like the cool, innovative products like rain-indexed weather insurance already existed, but very few knew of it. Very few carried it. And the vast majority didn't know about it, and it wasn't for the lack of trying that they didn't know about it. Hacks existed in the market. Even the poorest tenant farmer had a feature phone that gave him daily text messages about the commodity prices that evening. So what I'm trying to say is the thirst for knowledge is alive and kicking, and yet the access to information is lacking. And that access is only a smartphone away. But the jump from a handed-down feature phone to the smartphone with internet is too high for billions of people out there. And it is our moral duty to lower those barriers. We at Google believe that this access to information should never be at the cost of quality. And that is the reason we started the project we internally call Android Go. Android Go is the next phase of Google's investment after Project Svelte, the original Android One program, to connect the people who don't have the access to power of computing today and are not connected today. There are 3 hurdles to that access today. And the first and the most important of it is device affordability. OK, I'm going to take a poll. How many of you here use a cell phone that is less than $100? Raise your hands. Yeah. That is true. So now what I'm about to say, you'll understand much better, which is I personally dog food a lot of entry-level devices. And I can tell you, the experience is very humbling. So what we're doing for device affordability is the first thing we need to do is optimize our OS to run on the lowest common denominator of SoCs, memory chipsets, and screens. Memory as low as 512 megabytes of RAM. But you all know here, you're developers, OS isn't the game, right? The access to information comes through apps. So we're not just optimizing our OS, we're also optimizing our apps, and in sometimes writing new ones to meet the requirements of the next billion users. So the most important factor in all of this is not the apps we build, but the apps that you all build. And Patrick and I want to take this opportunity to talk to you about how can you write your apps for these next billion users. The next biggest hurdle to information after device affordability is data affordability. So when I talk to people who aren't connected yet, they tell me they want to use data. They're willing to pay for it, but they're very afraid. Data is still very expensive in large parts of the world. It's like money to them. MBs are like the new social currency. I kid you not, there are young people out there who gift their lovers 100 MB data packs. I'm not joking about that. That's actually true. It is like currency. So these users are willing to come online. They're willing to pay as long as they get control over where their precious MBs are spent. And that is the reason why we're building features into our OS and in our apps that increase the level of data transparency, as well as can give them additional controls to control their data. The third biggest factor and hurdle that we want to overcome is linguistic flexibility. Now, this is not simply adding more languages to the OS. Our users are increasingly wanting an exposure to a second language. People want their OS to be in English, but they want their special messaging app to be in Spanish. The same complexity exists in typing preferences, in searching preferences, and in my farmer's case, in browsing government websites. So we're building features into our apps that accommodate for this evolution of language and the preferences of the next billion users. So let's jump right in. Let's let Patrick tell you how we are solving for device affordability through performance, data affordability through better controls and transparency, and how we're solving for linguistic flexibility through multilingualism in our apps. Thanks.
Thanks, Arpit. So let's dive into what we're doing to optimize the phone experience. We're improving everything from the kernel to third-party applications. So let's start with the kernel. Most of our work in this area being around integrated Android lifecycle management with Linux. First, we spend time on tuning the kernel to be more optimized for the entry-level devices. This seems like a simple task, but it involves a lot of nitty-gritty details like tuning cache sizes, tuning swapping, tuning all kind of threading parameters, as Linux for a long time has been optimized for the server side. Even though Android has done a lot of changes, there's still a lot to do there. Then we implemented prioritized reclaiming of memory. I'll go into more details about that soon, as it's a key part of what we've done. And we've done better integration of memory events from Linux, allowing us to be much more proactive with cleaning up apps in the background and making sure we have more memory available. So under Go, we use Linux control groups that enables better resource management. C groups, as called in Linux, isolates each application and allows Android to prioritize memory collection and swapping for each application. We have then integrated that with Android's activity management, and that allows us to be much more aggressive of swapping away memory for low priority processes and better of selecting which processes to stop. Overall, this results in more memory being available for important applications, hence yours, and leading to a smoother user experience, even on a 512 megabyte to 1 gig device. To reduce the number of memory pages Android is using, we've optimized how DEX files are laid out in memory, as they currently tend to consume quite a lot of clean pages, leading to more swapping on entry-level devices. We're using profiling to redo the DEX layout and co-locate them. So we're taking, as you can see in this picture, we're taking code pages that is used and then bundling them together. And therefore, we're also creating more clean space for the kernel to collect. This improves both startup time and memory usage. It's also allowing then the kernel to be much more aggressive of collecting code pages that is not used on that platform. So we are doing innovations in the UI design. Let's talk about recents as an example. 95% of the time, our entry-level user only switch between their 4 recent applications. So we redesigned the UI to enable faster switching and save memory by reducing memory-intensive bitmaps. This is just one example of optimizations in the UI that we're doing to make it smoother, but also to fit the form factor. That's very different. And of course, like you will hear many times during my talks, save memory. So we are re-architecturing Google Play services. We're splitting the API services into dynamic modules. This reduces disk footprint, which is also a critical thing on these devices, but also, take a guess, reducing the memory footprint. This is very important as there is still a lot of APIs in Google Play services not used on enter-level devices in these markets. And of course, we're working on making applications to take less space, less memory, and consume less network. We've designed some brand new Google apps like YouTube Go, where we're also optimizing our existing apps like Chrome and Play and a lot of the pre-installed apps. These new Google apps aim to take less than 10 meg of APK size, and I'll talk more why 10 meg later on. Our OEM and carrier partners are also joining us, and we'll be creating optimized versions specifically for the entry-level devices to make sure that we keep the promise of the quality we want to deliver for this platform.
All right. So I'll talk about how we're solving for data affordability. I talked to you about how important it is for this set of users to have better controls and transparency about their data. Told you that is the key. So today, users have to type in a really complicated code, star, hash, 125, some number, followed by another complicated set of characters to find out their data balance. We want to make this super, super easy. We want to make this directly accessible with a downswipe from your quick settings. Now, to do that, we're creating an API where third-party developers or carriers could provide this information to the users by each data pack. So for their 4G data pack, their 3G data pack, their social media data pack, and so on. So all those balances would be available to the user right at their fingertips. Now, the next thing, once they come online, we want them to stay online, right? So imagine it's your regular Sunday afternoon. You're on your little messaging thread with your family. A heated political debate comes up. Your uncle just says the most provocative thing ever, and you have a witty comeback. But bam, your data runs out. Like, you don't want that to happen. It's happened to me. You really don't want that to happen. But jokes apart, our users actually travel for kilometers to recharge their phones or top up their phones. And oftentimes, when they reach that far, they still don't know, and even the seller doesn't know what the latest promotion by the carrier is. So what we want to do is create an API for the carriers to provide this latest information to the users and enable you to top up your data plans right there on the phone. So that's how we plan to do that. The next, these users see apps using data in the background as a hole in their wallet. They hate it. They hate it so much that they would either turn off the data altogether in the phone, which harms the whole point of this, which is to get them data information, or they delete your apps. They just absolutely delete your apps, which is horrible because you worked so hard to make them. So what we want to do is give them controls so that they can choose which apps get their MBs, or which apps choose it when. So that's how the OS is working hard to make sure there is transparency and controls. But our apps also pitch in. So let's talk about Chrome. Chrome has already launched this feature out, and today it is already saving 750 terabytes of data a day for the early adopters. On Chrome, data in Android Go, Chrome's data saver features would be turned on for default, so they don't have to opt in. And what it does, it transcodes data on its servers before it reaches you. Therefore, that's how we save you data. Second, it also detects when you're on a low connection and then gives you previews of pages, or that way helping you load the page and get the information faster. That's just Chrome. I want to talk about my favorite one of this, YouTube Go is an app that we had to build from scratch to meet the hard requirements that we put on ourselves. Once you start putting in the requirements of the lowest end SSEs and memory and the needs of the next billion users, we had to build this from scratch. Now, how many of you look for music videos on YouTube Go? All of you, right? So isn't it frustrating when you want to download and look at the latest Adele song, and it turns out to be another fan's karaoke video? Yeah, right. So imagine that frustration, even with people who have little data balance. That's really, really disappointing for them. So we built the preview feature so that people can preview what they're about to watch before they spend their precious few MBs doing that. And again, in this next billion users, you can't assume similar or constant data rates throughout the day. You can't assume the same level of connectivity. So we want to give users, again, additional control to choose the quality of video they want to watch. Next, some of the users might have a free Wi-Fi in their office. So we want them to have the ability to download these videos and watch them on their bus ride back. And the best of all, I don't know about you, but when I see a funny video, I have to share it, right? But I don't want these next billion users, or we don't want this next billion users, to have them pay for that video and have their friends pay for it too. So we're building offline, peer-to-peer sharing of videos within YouTube so that you don't have to pay for cellular data. So that's how we're saving for data. Now let's talk about solving for linguistic flexibility. When you want to express your thoughts and your ideas, Google Keyboard will come to your rescue. And this time, I'm not going to talk over it. I'm just going to show you. And we'll have some fun doing it. Patrick, I'll need your help. All right. If we can switch to my cell phone. All right. So Patrick is here. And I grew up in India, so I speak Hindi. So I want to switch over to typing phonetically in Hindi, but I want to write to him in Hindi. So let's say, Kaise ho dost, which means how are you, friend? I'm typing in English letters phonetically. It's going to him, and it's typing out in Hindi script, and it goes to him. But it so turns out that he's Swedish. He doesn't get my Hindi, right? So that sucks. So what can I do? So again, Google Keyboard to the rescue. I'll switch to translations. Now, I'm going to type in English letters in my native script and still send it to him. So let's try this again. Kaise ho dost. It translates to Swedish for me. And there you go. So if that doesn't get the geek out of you, then nothing else would. So that was Google Keyboard, right? So this is how you can express yourself better. And beyond that, Google Keyboard has 191 languages supported, 22 Indian languages supported. So this is all good. But what if you want to consume information, right? And at that point, Chrome comes. So Chrome will automatically detect, or Chrome it already detects, what your OS's language is. And any time you access information on a page that is different from your phone's language, it gives you proactive suggestions to translate it. And here's an example of that. So that'll help you consume information. It'll help that farmer I talked about consume the information in the language that's most comfortable to him. So that's all the translations. But you may ask, why does it matter? Why should you care?
So let's dig into that. So 1/3 of global shipments in 2017 will be sub-$100 devices. This is a must segment for developers that's focusing on the growing user base or focused on the mass market. So you may be thinking this is just a emerging market problem. But it turns out that's not true. This is not just an emerging market product. US is the second largest market for sub-$100 devices, as it's a huge prepaid market. Therefore, we're announcing, starting with OMR1, all devices shipping with 1 gig or less RAM will get Android Go configuration. And going forward, Android releases will have a Go configuration. So this is a sustained effort that will continue developing over time. So optimized Google Apps is a good start. But it's your apps that will really solve the needs of the next billion users. So let's see some hands. How many in here are optimizing for entry-level devices today? Yeah, that's quite few. How many in here think they need to optimize for low-end devices going forward? That's a lot more. That's very positive. I hope I see more hands next year during the first question. And to be honest, several of you have already jumped in, like Skype and Limelight. And I hope many more of you, after this talk, will start thinking seriously about these devices. Either develop new apps or optimizing your existing apps. So with Android Go, we have added targeting to the Play Store to help such apps get better distribution. And we'll continue surfacing these apps in more ways in the Play Store for entry-level devices. We've also optimized the Play Store to save more data, as data is very important in these markets. So we'll be supporting secure peer-to-peer transfer and installation of apps. And we'll also support delaying your download of the apps to a point when you may have a better data plan. Because it's quite common in these countries that you have much cheaper data during night when it's less congestion on the networks. So that's a feature you will be able to say, hey, download this automatically when I have a lower cost data plan. And the app will take care of understanding when in time that is, etc. So all of this is what we are doing, and it's a continuing, ongoing effort as we speak. Let's dive into what you should be doing as app developers. First, let's talk about data connectivity. 3G and LTE is growing around the world, and we're very happy for that. And 80% of the smartphones growth is in the emerging markets. But 2G will still be over 1 billion devices in 2020. So therefore, it's important to design apps that can handle slow and flaky connectivity. And it's important to create a useful experience for the users without or on bad networks. And don't forget to adjust when that changes, because networks in these countries and where is quite flaky and comes and goes. So you may have a very fast 4G, then you end up on Wi-Fi, then you have no connectivity. So think about optimizing for this and use the APIs that exist in the platform to detect this. One way to improve this handling, as shown here, is to prioritize text over heavy images. So show something relevant to the user while you can, because you don't know if the connectivity will disappear or become bad or worse. So low-end devices will continue to be memory restricted for quite some time going forward. So be efficient of how you use memory. Have short-lived services. Eliminate unneeded wake-ups. Use Firebase Job Dispatcher to handle network tasks. It's both network and battery aware. You can set policies around saying, hey, I only want to do this task if it's on an unmetered network. Have this same retry policy so that you don't consume a lot of power and battery without gaining anything for the users. Use Activity Manager is low RAM to adjust the experience and memory usage of your application, as that will be one of the ways we will signal you're on the Android Go platform. And that includes optimizing your images, as they can be quite big, and these devices are normally small displays, not a high resolution, not the best screen, so there's no need to save the images in super high resolution. But also size your caches correctly, think about how much you're caching, and anything else that may take memory. It'll be a constant trade-off on these devices. So think through what you're trying to give, what kind of experience you're trying to give your users. And also test. There is a lot of tools out there that allows you to simulate being on a 2G connection. It's quite revealing to do. At Google, we have Wi-Fi networks that simulate a poor 2G connection, and it's a horrible experience today. So I recommend doing that. So this is an example of using Android Studio Memory Monitor to measure the memory usage between two apps. One of the apps is using the app is using is low RAM flag to detect if you are on an Android Go device. It's automatically adjusts some image sizes and caches internally, and therefore it's quite easy to see the memory difference between them. The reason I have this here is to remind everyone in this room that Android Studio profiling tools are very powerful. There's been a lot of talks about them this week, and I strongly recommend you to check them out and use the tooling that we provide to help to optimize your app. We have tooling around the ability to look into your network traffic. You can see the distribution of network, CPU profiling, and memory profiling. So get on top of your app and see where are you consuming memory. So our research tells us that users that see an app greater than 10 meg as too heavy, and that means the user has a tendency to go and delete that app if they're running low on space. So 10 meg is kind of the breaking point where they think it's acceptable for app size in these markets. Image and language resources are the biggest offenders we've seen in apps, and therefore optimize your images, think about what you're trying to deliver, and be smart about translations. There's been quite a lot of talks again this week about this. I'll refer to some of them later. Remove code that you're not using. It's a simple task, but important. We are optimizing the kernel to be much better of collecting these code pages, but it's much easier if you haven't allocated them from the start. And don't forget to optimize for the smaller screens. That's something we spend quite a lot of time on, and I strongly recommend you do the same. And you may want to use multi-APK to get better targeting around this, so you can target these devices specifically. And one of the talks I strongly recommend is Engineering for High Performance with Tools. That was held this morning, if I remember correctly. So we've implemented a lot of new functionality in Android O to help improve memory and battery, like background check, that improves the system's ability to control and manage background services. It sets same limit of how often you can pull Wi-Fi and location, etc., depending on the conditions you're in. And therefore, for Android Go, we strongly recommend you to target Android O API level 26. I know this is very hard for existing applications, but it'll give the user quite a lot of benefits on this platform if you do. So important to say is that the changes I've been talking about is really good even for existing apps today. There is a lot of low-entry devices out there in the market as we speak, and the experience of them is quite poor as is. So this is something you really should be thinking about today, and the market is just growing. And having said that, we're planning to preview Android Go in the end of this year, and with the first devices shipping, first half of 2018. And you should start now and be ready for Android Go. And that's it. Thank you.